What mass of ethanol? So there's our ethanol. Let's put a question mark there. In kilograms, let's underline that. Let's double underline that because that means most people are going to get it wrong because calculating quantities questions always return answers in grams. So we'll need to convert at the end. One mass of ethanol in kilograms is needed to produce 1200 decimeter cubed of ethene. So 1200 decimeter cubed of ethene. So that's a gas. That's a volume of a gas. At room temperature and pressure. So we've got some relative atomic masses here, and we've also got the 1 mole of any gas at room temperature pressure occupies 24 decimeter cubed. Don't need the water, so we can cross that out. Right, so this is a calculating quantities questions. Calculating quantities questions always have 3 stages. First stage being moles. Second stage being the stoichiometry, look at the stoichiometry of the reaction. And the third stage being moles again. Okay, the trick is to identify the right moles equation for each stage. So we are given a volume of a gas, so we're going to need the gas moles calculation. And moles for gases is moles equals volume divided by 24. 24 is the molar gas constant, if you like, the amount the volume, if you like, a gas occupies at room temperature and pressure. So 1200 is our volume divided by 24 equals, get the calculator out, 50. We've got 50 moles of gas there. Okay, stoichiometry. Stoichiometry is the bit of the equation we haven't crossed out. So we've got C2H5OH, that's the ethanol, makes C2H4. Now, the important thing here is the big numbers before the substances. And as you can see, there are no big numbers. Therefore, it is one ethanol makes 1 ethene. What we can see from these numbers is they are the same, and we are going from there to there, and those numbers are the same. So the stoichiometry of this equation is 1 to 1. Now we don't start with we don't finish with 1 mole of ethene, we finish with 50 moles of ethene. And so looking at this relationship here is going to be made from the same volume of ethanol, 50 moles. So that's stage 2 done, 50 moles. Stage 3, we now want a mass of ethanol. So we need the moles equation that deals with mass. Moles equals mass over relative formula mass. I use the abbreviation MR. We need to rearrange this to make mass a subject, so that's going to be mass equals moles times relative formula mass of ethanol. Relative formula mass of ethanol, 2 carbons, 1 carbon is 12, so that's going to be 24, plus H5, hydrogen's 1, so that's going to be 5, plus 5, plus the oxygen, 1 oxygen, 16, plus 16, plus 1 hydrogen on the end, 1 hydrogen's 1. So that's going to be 24 and 6 is 30, 46 equals 46. So we need to do moles, which is 50. We got that from the previous stage there, 50. So that's going to be 50 times 46. 2,240, I don't know, let's have a look. So we're saying 50 times 46 equals 2,300. Not far off. Equals 2,300. And that answer is, of course, in grams. Okay, all these calculations return a mass in grams. Now, we don't want the answer in grams. We want it, if you remember at the start, we underline this so we didn't forget, in kilograms. How do we get grams to kilograms? We divide by 1,000. Equals 2.3 kg. And there's our final answer. All these questions and more on elshamhighchemistry.com.